Look up at the night sky on a clear evening, and you might see Mars, a reddish point of light that has captivated human imagination for millennia. Ancient civilizations saw this wandering star and named it after their gods of war, struck by its blood-red color. The Egyptians called it Her-Desher, the Red One. The Romans named it Mars after their god of war. For thousands of years, Mars has been a symbol of mystery and otherness, a world that seemed unreachably distant yet tantalizingly visible, a beacon in the darkness suggesting that Earth might not be alone in the cosmos. But Mars is not just a symbol or a myth. It is a real place, a world with its own geography, geology, weather, and history. It is a planet roughly half the diameter of Earth, with a mass about 1/10 that of our home world. Its surface area is about equal to all the land area on Earth, meaning that Mars has roughly the same amount of dry land as our planet. Though Mars has no oceans, no liquid water on its surface at all, it is a cold, dry, dusty world, with temperatures that plunge far below freezing, even at the equator, and an atmosphere so thin it is almost a vacuum, offering no protection from radiation and no oxygen to breathe. Yet for all its harshness, Mars is the most Earth-like planet in our solar system. It has seasons caused by the tilt of its axis, much like Earth's seasons. It has polar ice caps that grow and shrink with the seasons. It has weather patterns, including dust storms that can engulf the entire planet. It has mountains, valleys, canyons, and ancient riverbeds, evidence that liquid water once flowed on its surface billions of years ago. It has a day that is remarkably similar to Earth's, just slightly longer at about 24.5 hours. In many ways, Mars is our closest cosmic neighbor in terms of habitability, the next best option after Earth for human settlement. This raises the question that has driven space exploration for decades. Can humans live on Mars? Not just visit, as we did with the Moon, but truly live there, establish permanent settlements, raise families, build cities, create a new branch of human civilization on another world? The question is not merely technical, though the technical challenges are immense. It is also philosophical, psychological, ethical, and existential. What would it mean to become a multi-planetary species? What would we gain, and what would we lose? What are the risks, and are they worth taking? The dream of settling Mars is as old as science fiction itself. Writers have imagined Martian colonies for over a century, from Edgar Rice Burroughs' romantic adventures to Kim Stanley Robinson's meticulous terraforming trilogy. These stories have shaped how we think about Mars, planting the idea that it is our destiny to expand beyond Earth, to carry life and consciousness to other worlds. But reality is always more complex than fiction, and the actual process of settling Mars will be far harder, stranger, and more ambiguous than any novel can capture. Let us begin with the technical challenges, for they are formidable and give us a sense of the scale of what settling Mars would require. First, there is the journey itself. Mars is not close. At its nearest approach to Earth, it is still about 55 million kilometers away, and at its farthest, it is over 400 million kilometers distant. These distances mean that travel to Mars takes many months, typically 6 to 9 months, with current propulsion technology. During this journey, astronauts would be exposed to cosmic radiation, confined in small spaces, isolated from Earth with communication delays of many minutes, and psychologically challenged by the knowledge that they cannot turn back. The radiation exposure is particularly concerning. In space, beyond Earth's protective magnetic field and atmosphere, astronauts are bombarded by high-energy particles from the sun and from deep space. These particles can damage DNA, increasing the risk of cancer and other health problems. On a multi-month journey to Mars, astronauts would receive radiation doses far exceeding what is considered safe for humans. Shielding can reduce this exposure, but the mass required for effective shielding makes spacecraft prohibitively heavy and expensive. New technologies such as magnetic shielding or water-filled walls are being explored, but none are yet proven for long-duration spaceflight. Then there is the challenge of landing on Mars. The Martian atmosphere is thick enough to cause heating during entry, but too thin to slow a spacecraft sufficiently with parachutes alone. This has led engineers to develop complex landing systems involving heat shields, parachutes, and retrorockets, all operating in precise sequence. The 7 minutes of terror, as NASA engineers call the entry, descent, and landing phase, is a nail-biting period during which everything must work perfectly, and communication delays mean that controllers on Earth can only watch helplessly, unable to intervene if something goes wrong. Many missions to Mars have failed during landing, a reminder of how difficult it is to reach the surface intact. Once on Mars, settlers would face an environment that is hostile to human life in almost every way. The atmosphere is mostly carbon dioxide, with only trace amounts of oxygen, so humans cannot breathe it. The atmospheric pressure is less than 1% of Earth's sea level pressure, so low that liquid water cannot exist on the surface except briefly under special conditions. A human exposed to the Martian surface without a spacesuit would lose consciousness within seconds and die within minutes from lack of oxygen and the effects of near vacuum pressure. The cold is extreme, with average temperatures around -60 degrees Celsius and nighttime temperatures dropping below -100 degrees. The surface is bathed in ultraviolet radiation and cosmic rays, with no magnetic field or thick atmosphere to provide protection. Living on Mars would mean living in sealed habitats, wearing spacesuits for any work outside, and constantly managing life support systems that provide air, water, food, and temperature control. These habitats would need to be robust, capable of withstanding dust storms, temperature fluctuations, and the slow degradation that comes from the harsh environment. They would need to be redundant, with backup systems for critical functions, because failure could mean death. And they would need to be expandable, growing as the population grows, adding new modules, new greenhouses, new industrial facilities. Producing food on Mars is another major challenge. Earth's soil is rich with organic matter and microorganisms that help plants grow. Martian soil, or regolith, is chemically different, containing perchlorates that are toxic to plants and lacking the organic content needed for agriculture. Plants could potentially be grown in Martian regolith if it is treated and supplemented with nutrients, but this requires significant processing. More likely, initial Mars settlements would rely on hydroponics or aeroponics, growing plants in water or mist without soil in controlled greenhouse environments. These systems can be efficient, but require energy, water, and nutrients that must be sourced locally or brought from Earth. Water is essential for life and for growing food, and Mars does have water, mostly locked up in ice at the poles and in underground deposits. Extracting this water, melting it, purifying it, and distributing it would be one of the primary tasks of a Mars settlement. Water is also valuable because it can be split into hydrogen and oxygen, providing oxygen for breathing and hydrogen as a fuel, or for combining with carbon dioxide to make methane, which can be used as rocket fuel. The ability to produce propellant on Mars is crucial for any plan to return astronauts to Earth or to support ongoing travel between Earth and Mars. Energy is another fundamental requirement. On Earth, we have abundant sunlight, fossil fuels, hydroelectric power, wind, and nuclear energy. On Mars, solar panels can provide energy, but they are less efficient due to the greater distance from the sun and the frequent dust storms that block sunlight and coat panels with dust. Nuclear reactors, particularly small modular reactors designed for space applications, might be a better option, providing reliable power regardless of weather or the day-night cycle. But nuclear reactors are complex, require careful handling, and raise concerns about safety and waste management. These technical challenges are daunting, but they are not insurmountable. Humans have solved difficult engineering problems before. We built cities in deserts, in the Arctic, on isolated islands. We created the International Space Station, where astronauts have lived continuously for over 2 decades. We sent robots to Mars and successfully operated them for years. The question is not whether we can solve the technical problems, but whether we will choose to invest the resources and take the risks necessary to do so. But beyond the technical challenges, there are deeper questions about why we would want to live on Mars at all. What drives the impulse to leave Earth and settle another world? For some, it is about survival. Earth is vulnerable to catastrophic events, asteroid impacts, supervolcano eruptions, pandemics, nuclear war, climate change. By establishing a self-sustaining settlement on Mars, humanity would have a backup, a second home that could survive even if Earth became uninhabitable. This is sometimes called the planetary backup argument, and it has a certain logic. If all of humanity is on one planet, we are all vulnerable to the same catastrophes. Spreading to multiple planets reduces the existential risk to our species. But this argument has limitations. Mars is harsh and would support only a tiny fraction of Earth's population, at least initially. If Earth became uninhabitable, billions would still perish, and only a lucky few on Mars might survive. Moreover, Mars itself is vulnerable. It lacks a magnetic field and has a thin atmosphere, making it susceptible to radiation and meteorite impacts. It is not a safe haven in any absolute sense, just a different set of risks. The planetary backup argument provides some rationale for Mars settlement, but it is not compelling enough on its own to justify the enormous effort and expense. Another motivation is exploration and knowledge. Mars is a scientifically fascinating world. It once had liquid water on its surface, and where there is water, there is at least the possibility of life. Did life ever arise on Mars? If so, did it survive underground in pockets of liquid water beneath the surface? Finding evidence of past or present life on Mars would revolutionize our understanding of biology and our place in the universe. It would tell us that life is not unique to Earth, that the processes that led to life here can occur elsewhere, and that the universe might be teeming with life in all its diverse forms. This is a powerful scientific motivation, though it does not necessarily require human settlement. Robots can explore Mars and search for life, as they have been doing for decades. A third motivation is expansion and growth. Humans have always been explorers, pushing into new territories, settling new lands, expanding the reach of civilization. This drive to explore and expand is part of our evolutionary heritage, shaped by millions of years of migration and adaptation. Mars represents the next frontier, the next challenge, the next destination for this ancient urge. Some argue that settling Mars is inevitable, that it is in our nature to spread, and that preventing this expansion would be stifling a fundamental human impulse. But this argument also has its critics. Expansion for its own sake can be destructive, leading to the exploitation of environments and the displacement of existing inhabitants, as human history amply demonstrates. While Mars has no indigenous inhabitants to displace, the expansionist mindset has led to environmental degradation on Earth, and there is concern that we would bring the same destructive habits to Mars. Moreover, the resources required to settle Mars could arguably be better spent addressing problems on Earth: poverty, disease, climate change, inequality. Why invest trillions in colonizing a barren desert planet when Earth, a paradise by comparison, is suffering from neglect and mismanagement? This tension between terrestrial and extraterrestrial priorities is real and important. Some see space exploration as a distraction from urgent problems on Earth, a luxury we cannot afford while millions lack basic necessities. Others see it as complementary, arguing that the technologies developed for space can benefit Earth, that the perspective gained from seeing Earth from space inspires environmental awareness, and that investing in the future is as important as addressing the present. Both perspectives have merit, and the balance between them is a matter of values and priorities. There is also a more philosophical motivation for settling Mars, one that is harder to articulate but deeply felt by many space advocates. It is the idea that becoming a multi-planetary species represents a new chapter in human evolution, a transformation from a species bound to a single planet to one that inhabits multiple worlds. This transformation would change how we see ourselves, expand our sense of identity from Earthlings to solar system dwellers, and perhaps eventually to citizens of the galaxy. It is a grand vision, one that appeals to our sense of destiny and purpose, suggesting that we are meant for more than just living out our existence on Earth. This vision is inspiring, but it also raises questions. Who gets to decide humanity's destiny? Who represents humanity in making these choices? Space agencies and private companies are currently driving Mars exploration, but they are not democratic institutions accountable to all of humanity. The decisions about whether and how to settle Mars are being made by relatively small groups of scientists, engineers, entrepreneurs, and policymakers, mostly in wealthy nations. Is this appropriate? Should there be global deliberation and consensus about such a momentous step? Or is it acceptable for those with the means and the will to lead the way, with others following later? These questions touch on issues of justice, equity, and representation. Space exploration has historically been the domain of superpowers competing for prestige and strategic advantage. The space race between the United States and the Soviet Union was driven more by Cold War politics than by scientific curiosity or human unity. Today, private companies like SpaceX are leading the charge toward Mars, motivated by the vision and ambition of individuals like Elon Musk. This raises concerns about the privatization of space, the possibility that Mars could become a domain for the wealthy and powerful, while the rest of humanity is left behind. There are also ethical questions about how we should treat Mars itself. Mars is a pristine environment untouched by life for billions of years, assuming it never had life or that any life it had is long extinct. Do we have the right to alter Mars, to bring Earth life there, to potentially contaminate it with our microbes? This is the issue of planetary protection, which has both scientific and ethical dimensions. Scientifically, we want to study Mars as it is without contamination from Earth, so we can learn its true history and determine whether it ever had indigenous life. Ethically, some argue that Mars has intrinsic value, that it is not just a resource for human use, but a world with its own integrity that we should respect. This ethical stance is sometimes called environmental ethics extended to other planets. Just as we have come to recognize that Earth's ecosystems have value beyond their utility to humans, perhaps we should recognize that other worlds have value in themselves. Destroying Mars's pristine state to make it habitable for humans could be seen as an act of cosmic vandalism, prioritizing human needs over the preservation of a unique and irreplaceable environment. On the other hand, others argue that Mars, being lifeless, has no interests or welfare to protect, and that transforming it to support life is not destructive but creative, bringing value and richness to a barren world. This debate parallels debates on Earth about development versus conservation. Some see nature as valuable primarily for its utility to humans, while others see it as valuable in itself, deserving of protection regardless of its usefulness. Applied to Mars, these views lead to very different conclusions about how we should approach settlement and terraforming. Terraforming, the process of altering Mars to make it more Earth-like, is the ultimate expression of the utilitarian view, reshaping an entire planet to suit human needs. But it would irreversibly change Mars, erasing its current state forever. Terraforming Mars is a concept that has fascinated scientists and science fiction writers for decades. The basic idea is to warm the planet, thicken its atmosphere, and introduce water and oxygen, gradually transforming it from a cold, dry, airless world to one where humans could live on the surface without spacesuits. This is a multi-century, or even multi-millennial project, requiring technologies and resources on a planetary scale. Proposals include releasing greenhouse gases to warm the planet, melting the polar ice caps to release water and carbon dioxide, importing volatiles from asteroids or comets, and introducing photosynthetic organisms to produce oxygen. Each step of terraforming presents enormous challenges. Warming Mars enough to support liquid water on the surface would require increasing the greenhouse effect dramatically. But Mars has lost most of its atmosphere over billions of years due to solar wind stripping, and it continues to lose atmosphere today. Without a magnetic field to protect the atmosphere, any gases we add would gradually be lost to space. Some proposals involve creating an artificial magnetic field to shield Mars, but this is far beyond our current technological capabilities. Others suggest that we could continuously replenish the atmosphere faster than it is lost, but this would require sustained effort over geological timescales. Even if we could warm Mars and thicken its atmosphere, producing breathable air would take many centuries. Oxygen would have to be generated by splitting water or by photosynthetic organisms, and enough would have to accumulate in the atmosphere to support human respiration. This process would likely take thousands of years, even with aggressive efforts to accelerate it. During this time, settlers would still need to live in sealed habitats or wear pressure suits and respirators. Terraforming is not a quick solution to the challenges of living on Mars, but a long-term vision that would benefit distant future generations more than the initial settlers. Moreover, terraforming assumes that we can successfully manage planetary-scale engineering, a presumption that should give us pause. On Earth, our attempts to manage ecosystems and climate have often had unintended consequences. Introducing species to new environments has sometimes led to ecological disasters. Our industrial activities have warmed the planet and destabilized the climate in ways we are struggling to control. Do we have the wisdom and competence to engineer an entire planet deliberately? Or would we likely make catastrophic mistakes, creating a Mars that is neither the pristine world it was nor the habitable paradise we hoped for, but something in between, damaged and dysfunctional? These concerns suggest that we should approach Mars settlement, and especially terraforming, with humility and caution. We should not assume that we have the right or the ability to reshape worlds at will. We should proceed carefully, learning as we go, respecting the limits of our knowledge and the potential for harm. This cautious approach might mean that Mars settlement progresses more slowly than enthusiasts hope, but it might also mean that we avoid irreversible mistakes that could compromise the future of both Mars and humanity. Let us turn now to the human dimension of living on Mars, for settling another world is not just a technical challenge but a profoundly human one. What would it be like to live on Mars? How would the experience of life change in such a different environment? These questions touch on psychology, sociology, culture, and the very nature of human identity. First, consider the isolation. Mars settlers would be separated from Earth by vast distances and significant time delays. Communication with Earth would take between 3 and 22 minutes one way, depending on the relative positions of the planets. This means that real-time conversation would be impossible. Every exchange would involve waiting minutes or even tens of minutes for a response. This delay would fundamentally change the nature of communication, making it more like exchanging letters than having a conversation. Settlers could not call home for immediate advice or comfort. They would be on their own, forced to be self-reliant in ways that earthbound humans rarely are. This isolation could be psychologically challenging. Humans are social creatures, and we rely on connection to others for emotional well-being. Being cut off from most of humanity, unable to see friends and family except through delayed video messages, could lead to feelings of loneliness, alienation, and depression. The initial settlers would need to be carefully selected for psychological resilience, and the community on Mars would need to develop strong social bonds and support systems to help individuals cope with the isolation. But isolation could also have positive aspects. It could foster a strong sense of community among the settlers, a shared identity as Martians, pioneers on the frontier of human civilization. It could encourage self-sufficiency and creativity, as settlers would need to solve problems with the resources at hand rather than relying on supplies from Earth. It could create a unique culture, distinct from Earth cultures, shaped by the specific challenges and opportunities of life on Mars. Over time, Martian culture might diverge significantly from Earth culture, developing its own values, customs, and traditions. Then there is the physical environment. Gravity on Mars is about 1/3 of Earth's gravity. This has significant health implications. In low gravity, bones lose density, muscles atrophy, and the cardiovascular system weakens because it does not have to work as hard to pump blood. Astronauts on the International Space Station, where there is microgravity, experience these effects, and they require intensive exercise regimens to mitigate them. On Mars, the gravity is higher than on the ISS, but still much lower than on Earth. Would 1/3 gravity be enough to maintain health over a lifetime? Would children born on Mars develop normally, or would the low gravity affect their physical development in ways we cannot predict? These are open questions that we will not fully answer until humans actually live on Mars for extended periods. Animal studies in varying gravity conditions could provide some answers, but ultimately we will need to observe humans living on Mars to know for sure. This uncertainty is one of the risks settlers would face. The possibility that long-term residence on Mars could have health consequences that we do not anticipate and cannot easily reverse. There is also the question of children. If Mars is to be a true settlement rather than just an outpost, children will need to be born and raised there. But what kind of life would a child have on Mars? They would grow up in sealed habitats, unable to play outside without a spacesuit, never experiencing open sky, rain, oceans, forests, or the rich sensory environment that Earth children take for granted. Would they feel deprived, or would they adapt, finding joy and wonder in their own environment? Would they develop a different relationship to nature, seeing it through the lens of life support systems and greenhouses, rather than as a wild and abundant presence? Children born on Mars might never visit Earth. The low gravity they grow up in could make it difficult or impossible for them to adapt to Earth's higher gravity. Their bodies might not develop the bone density and muscle strength needed to function on Earth. They might be adapted to Mars, unable to live on the planet that gave birth to their species. This would be a profound shift in human identity, the creation of people who are Martians first, humans second, whose home is Mars, and for whom Earth is an alien world. This raises questions about rights and identity. Would people born on Mars be Martian citizens, Earth citizens, or both? Who would govern Mars, and how would its political relationship with Earth be structured? Would Mars be a colony dependent on and subordinate to Earth? Or would it quickly assert independence, becoming a separate polity with its own government and laws? History suggests that colonies eventually seek independence, and it is hard to imagine that a Martian settlement would remain content to be governed from a planet millions of kilometers away, with communication delays that make responsive governance impossible. The possibility of Martian independence raises geopolitical questions. Would Mars and Earth have peaceful relations, cooperating and trading, or would there be conflict, competition, and possibly war? Science fiction has explored many scenarios, from harmonious multi-planetary civilization to interplanetary conflict. The reality will depend on the values and choices of the people involved, on whether we can extend principles of cooperation, justice, and mutual respect beyond Earth, or whether we will replicate the patterns of exploitation, conflict, and domination that have characterized human history. There is also the question of meaning and purpose. What would give life meaning on Mars? On Earth, people find meaning in many ways, through relationships, work, creativity, spirituality, connection to nature, participation in community. Some of these sources of meaning would translate to Mars, while others might be absent or transformed. Relationships and community would still be central, perhaps even more so in a small, isolated settlement where everyone depends on each other. Work would be essential, as maintaining a Mars settlement would require constant effort from everyone. but connection to nature might be different. Mars has no biosphere, no living nature to connect with. Nature on Mars would be the stark beauty of rock and dust, the alien sky, the slow dance of the moons Phobos and Deimos. Would this be enough, or would settlers long for the green hills and blue oceans of Earth? Some might find profound meaning in the act of settlement itself, and being pioneers, and contributing to the expansion of human civilization, and knowing that they are part of a historic undertaking. This sense of purpose could be a powerful source of meaning, providing direction and motivation even in the face of hardship. But it is also possible that some settlers would feel that the sacrifice is not worth it, that they have given up too much for too little, that Mars is a cold and barren place that can never truly be home. This brings us to the question of home. What does it mean to be home? For most people, home is Earth, the planet where we evolved, where our ancestors lived, where life as we know it flourishes. Earth is our home not just because we happen to live here, but because we are adapted to it, shaped by it, dependent on it in countless ways. Can Mars become home in the same deep sense, or will it always feel like exile, a place we live but do not truly belong? Perhaps over generations, Mars could become home for those born there, for people who have never known Earth, for whom Mars is the only world they have ever experienced. For them, the red deserts and thin air and low gravity would be normal, and Earth would be the strange and alien place. But for the first settlers, the generation that remembers Earth, Mars might always be a frontier, a place of opportunity and challenge, but not truly home. This generational difference could create tensions within the Martian community, between those who long for Earth and those for whom Earth is just a distant legend. Despite all these challenges, there is something compelling about the vision of humans on Mars. It represents hope, ambition, the refusal to be limited by circumstance, the belief that we can shape our destiny and extend our reach to new worlds. It embodies the explorer spirit that has driven human achievement throughout history, from the first humans leaving Africa to the first navigators crossing oceans to the first astronauts leaving Earth. Mars is the next step in that journey, a continuation of the story of human expansion and adaptation. But it also represents a test of our wisdom and maturity as a species. Can we settle Mars responsibly with respect for the environment and consideration for future generations? Can we do it cooperatively, as a species working together rather than as nations and corporations competing for advantage? Can we do it justly, ensuring that the benefits and burdens are fairly distributed? These are not just technical questions, but moral ones, and how we answer them will say much about who we are and what we value. Will we live on Mars? The answer depends on many factors, some technical, some economic, some political, some philosophical. It depends on whether we can solve the engineering challenges, whether we can afford the enormous costs, whether we can muster the political will, whether we can agree on why and how to do it. It depends on whether we choose to prioritize Mars settlement over other urgent needs, whether we can do it without harming Earth or Mars, whether we can create a just and sustainable human presence on another world. My own sense is that we probably will send humans to Mars at some point in the coming decades. The technological trajectory is moving in that direction, the economic incentives are growing, and the cultural fascination with Mars is strong. But whether we will truly settle Mars, establishing permanent, self-sustaining communities, is less certain. Settlement requires not just visiting, but staying, not just surviving but thriving, not just enduring but building a life worth living. That is a much higher bar, and it is not clear we are ready to meet it. Perhaps we should focus first on living sustainably on Earth, on solving the problems we have created here, before exporting them to other worlds. Perhaps we should use the perspective gained from space exploration to appreciate Earth more deeply, to recognize its fragility and preciousness, to commit to preserving and restoring it. Mars can inspire us, challenge us, teach us about our capabilities and limitations, but it should not distract us from the urgent work of caring for the world that has given us life. At the same time, there is value in having goals that stretch beyond the immediate, visions that inspire us to reach further than we thought possible. Mars represents such a vision. Even if we never settle there in large numbers, the effort to try will drive innovation, foster cooperation, and expand our understanding of what it means to be human in a vast and ancient cosmos. The journey toward Mars, whether or not we complete it, is worth taking for what it teaches us along the way. So will we live on Mars? Perhaps. Perhaps some of us will, while others remain on Earth. Perhaps future generations will look back at our time as the moment when humanity began to spread beyond its home planet, taking the first tentative steps toward becoming a multi-planetary species. Or perhaps they will see it as a brief moment of overreach, a dream that proved too difficult or too costly, abandoned in favor of more pressing concerns. Either way, the question itself is worth asking, and the attempt to answer it through thought and exploration and bold action is part of what makes us human. As you drift toward sleep, imagine for a moment what it would be like to stand on the surface of Mars. You are wearing a spacesuit, and through the faceplate you see a landscape unlike anything on Earth. Red-orange soil stretches to the horizon, punctuated by rocks and boulders. In the distance you see the rim of a crater, and beyond that, mountains rising against a butterscotch sky. The sun is smaller than you are used to, about 2/3 the size it appears from Earth, and the sky around it is not blue, but a dusty tan, fading to dark blue near the horizon. Two tiny moons, Phobos and Deimos, move quickly across the sky, neither round like Earth's moon, but lumpy and irregular, captured asteroids orbiting the planet. You take a step, and you are surprised by how light you feel, how easy it is to move in the low gravity. You could almost imagine jumping high into the air, though the bulky spacesuit constrains you. You bend down and pick up a rock, turning it over in your gloved hand. This rock has been here for billions of years, untouched by life, shaped only by wind and temperature and the slow processes of geology. You are perhaps the first living being to ever touch it, the first conscious mind to contemplate it. You look back at your habitat, a cluster of modules connected by tunnels, with solar panels and antennas extending from them. Inside are your companions, the people you will live and work with for months or years, the small community that is your world now. Beyond the habitat, far beyond, lies Earth, a pale blue dot in the sky, rising in the evening, a reminder of home, of the billions of people continuing their lives while you stand here, so far away, on the edge of what humans have achieved. Is this your future? Will you or your children or their children stand on this alien world, looking up at two moons and a distant Earth, calling Mars home? The answer is not yet written. It will be determined by choices we make, actions we take, values we uphold. Mars is waiting, patient and silent, a challenge and an opportunity, a mystery and a mirror. What we see there, what we do there, will reflect back on who we are and what we hope to become. Rest now, let these thoughts settle. Mars is not going anywhere. It will still be there tomorrow, still red, still cold, still waiting. And we will still be here on Earth, still dreaming, still planning, still wondering if we will someday make that other world our home. For tonight, this is enough. Tomorrow will bring its own questions and possibilities. Sleep well. But before we let sleep take us completely, let us linger a bit longer on this question of Mars, for there are depths we have not yet explored, dimensions of the question that deserve our attention. The dream of living on Mars is not just about survival or exploration or expansion. It is about transformation, about becoming something more than we have been, about testing the limits of human adaptability and ingenuity. Consider what it would mean for human biology to adapt to Mars over many generations. The low gravity would reshape our bodies. Children born and raised in 1/3 Earth gravity would develop different skeletal structures, different muscle mass, different cardiovascular systems. Their bodies would be optimized for Martian conditions, but this optimization would come at a cost. They might never be able to visit Earth, never experience full gravity without their bones and muscles being unable to support their own weight. They would be a new branch of humanity, Homo Martianus perhaps, physically distinct from Homo sapiens, adapted to a different world. This divergence raises profound questions about human identity and unity. If Martian humans become biologically distinct from Earth humans, are we still one species? Would we still see each other as kin, or would we diverge not just physically, but psychologically, culturally, politically? Would the shared heritage of evolving on Earth be enough to maintain connection? Or would the different environments produce such different experiences and values that Martians and Earthlings would become truly alien to each other? Science fiction has explored these possibilities extensively. In some stories, Martians and Earthlings maintain peaceful relations, celebrating their diversity while recognizing their common origin. In others, the divergence leads to misunderstanding, resentment, and conflict. Earth might see Mars as a rebellious colony that needs to be controlled. Mars might see Earth as a decadent, overpopulated world clinging to past glories. These are speculative scenarios, but they are grounded in the reality that different environments shape different peoples, and that unity requires effort, communication, and mutual respect. The physical transformation would be accompanied by psychological and cultural changes. Living on Mars would require a different mindset than living on Earth. On Earth, we take for granted that we can step outside and breathe, that water is abundant, that the environment is basically hospitable to human life. These assumptions are so deeply embedded in our psychology that we barely notice them. On Mars, none of these assumptions hold. Every breath requires a life support system. Every drop of water is precious. The environment is actively hostile, and survival requires constant vigilance and maintenance. This constant awareness of dependence on technology, of the fragility of life, of the thinness of the margin between survival and death, would shape Martian psychology profoundly. Martians might develop a different relationship to risk, a different appreciation for cooperation and community, a different understanding of the value of life. They might be more cautious, more disciplined, more focused on long-term sustainability than on short-term gratification. Or they might develop the opposite traits, becoming risk-takers who thrive on the edge, who find meaning in confronting danger and overcoming challenges. The culture that develops on Mars would also be influenced by who the settlers are and where they come from. The first settlers would likely be highly educated, technically skilled, psychologically resilient individuals from wealthy nations with space programs. But as settlement progresses, the demographics would diversify. Would Mars attract people fleeing problems on Earth, seeking a fresh start on a new world? Would it become a destination for the adventurous and the ambitious, or for the desperate and the disenfranchised? The mix of people would determine what kind of society develops. There is a romantic vision of Mars as a place where humanity can start over, leaving behind the mistakes and injustices of Earth, building a better society from scratch. This vision has appeal, the idea that on Mars we could create a more equitable, sustainable, harmonious civilization, learning from Earth's failures and embodying our highest ideals. But history suggests skepticism. Humans carry their values, prejudices, and patterns of behavior with them wherever they go. The colonization of the Americas, Australia, and other regions did not lead to utopias, but to the replication and often intensification of the very problems the colonizers were fleeing. Mars settlers would be human, with all the strengths and weaknesses that entails, and there is no guarantee that they would build a better society just because they are on a different planet. Moreover, the harsh environment of Mars might encourage authoritarian tendencies. In a place where life depends on complex technological systems, where mistakes can be fatal, there might be pressure to prioritize efficiency and order over freedom and diversity. A Martian settlement might develop a strict, centralized governance structure with little tolerance for dissent or deviation, because the risks of chaos or incompetence are too high. This would be a tragic irony, seeking freedom and opportunity on a new world, only to create a society more restrictive than the one left behind. On the other hand, the small size and isolation of early Martian settlements might foster genuine democracy and community. In a small group where everyone knows everyone else, where survival depends on cooperation, where there is no higher authority to appeal to, people might develop strong norms of mutual respect, collective decision-making, and shared responsibility. The Martian community might be more egalitarian, more participatory, more responsive to individual needs than large, impersonal Earth societies. This is a more hopeful vision, and it is not impossible, but it would require conscious effort and commitment to maintain. Let us think now about the economy of a Martian settlement. What would people do for work? How would resources be allocated? What would constitute wealth and value on Mars? In the early stages, almost all work would be focused on survival, maintaining life support systems, growing food, extracting water and resources, building and repairing infrastructure. There would be little surplus for luxuries or diversions. Everyone would need to contribute, and the division of labor would be practical and flexible, with people doing whatever needs to be done rather than specializing narrowly. As the settlement grows and becomes more self-sufficient, economic activity would diversify. There would be opportunities for innovation, for creating new technologies adapted to Martian conditions, for producing goods and services for the local population. But Mars would also need to trade with Earth. What would Mars have to offer? Raw materials like metals and minerals could be valuable, but transporting them to Earth is expensive. More likely, Mars would export knowledge, data, and intellectual property, scientific discoveries, technological innovations, cultural products. Mars might become a center for research and development, a place where people work on cutting-edge problems in a unique environment. Tourism is another possibility. Once travel to Mars becomes more routine and affordable, some people might want to visit, to experience life on another world, to see the landscapes and habitats, to say they have been to Mars. This would create an industry around hospitality and experiences. But tourism requires infrastructure and raises questions about how to manage visitors without disrupting the settlement or overwhelming its resources. The currency of Mars is another interesting question. Would Mars use Earth currencies or develop its own? In the early stages, the settlement might operate on a planned economy, with resources allocated centrally based on need rather than market transactions. But as the economy grows, a market system might emerge with prices and exchange facilitating the allocation of goods and services. The development of a Martian economy would mirror the development of economies on Earth, moving from simple barter or command systems to more complex market structures with all the attendant benefits and problems. Ownership and property rights on Mars are also contentious issues. Who owns Mars? By international treaty, no nation can claim sovereignty over celestial bodies, but this does not resolve questions of land ownership, resource rights, or jurisdiction. If a company or individual invests in building a habitat on Mars, do they own the land it sits on? Can they exclude others from it? What about the resources they extract, the water they mine, the minerals they process? These questions have no clear answers under current international law, and they will need to be addressed as Mars settlement becomes real. There is a danger that Mars could become a domain for the wealthy and powerful, with land and resources claimed by those who get there first or who have the capital to invest. This would replicate the patterns of colonialism and capitalism on Earth, with all the inequality and exploitation those systems entail. Alternatively, Mars could be treated as a commons, a shared heritage of humanity, with resources managed collectively for the benefit of all. This would require international cooperation and governance structures that do not yet exist, but could be developed if there is political will. The question of governance on Mars is central to its future. Who makes the rules? Who enforces them? How are disputes resolved? In the early stages, Mars settlers might be employees of space agencies or private companies, subject to the rules and authority of those organizations. But as settlements become permanent and populations grow, there would be pressure for self-governance, for settlers to have a say in the decisions that affect their lives. This could lead to the development of Martian political institutions, councils, assemblies, courts, perhaps eventually a Martian government independent of Earth. The relationship between Martian government and Earth governments would be complex. Would Mars be a protectorate, a territory, a colony, or an independent polity? Would it have representation in Earth political bodies, or would it be sovereign and self-determining? These are questions that have been asked before in Earth history, whenever new territories were settled or colonies sought independence. The answers depend on power dynamics, legal frameworks, and the values of the people involved. One hopeful possibility is that Mars could pioneer new forms of governance, experimenting with political systems that have not been tried on Earth or that have failed there due to entrenched interests and historical inertia. Mars could be a laboratory for democracy, for participatory governance, for alternative economic systems, for new ways of organizing society. This would require vision, courage, and willingness to learn from failure, but it is one of the most exciting aspects of the Mars Settlement Project, the opportunity to reimagine how humans live together. Let us turn now to the question of meaning and purpose on Mars, for this is ultimately what will sustain settlers through the hardships they will face. Why would someone choose to leave Earth, to spend months traveling through space, to live in a harsh and dangerous environment, to be separated from most of humanity? What would make such a life worthwhile? For some, the answer is adventure and exploration. Mars represents the ultimate frontier, a challenge that tests human limits, an opportunity to be part of something historic and meaningful. The first settlers would be pioneers, their names remembered for generations, their achievements celebrated as a turning point in human history. This sense of participating in something larger than oneself, of contributing to the expansion of human civilization, could be a powerful source of meaning. For others, the answer might be escape or renewal. Earth is crowded, polluted, constrained by history and convention. Mars offers a chance to start fresh, to build a new life in a new place, to leave behind the problems and limitations of the old world. This is the classic immigrant narrative, and it has motivated people throughout history to cross oceans and mountains in search of better opportunities. Mars is the next destination for this ancient human impulse. For still others, the answer might be scientific curiosity. Mars is a laboratory for studying planetary formation, climate change, the possibility of life beyond Earth. Living on Mars would provide opportunities for research that cannot be done remotely, for hands-on exploration of the planet's geology, atmosphere, and potential biology. Scientists might find deep satisfaction in this work and contributing to human knowledge, in solving mysteries that have puzzled us for centuries. But not everyone who goes to Mars will find meaning there. Some will feel that they have made a terrible mistake, that the sacrifices are too great, that Mars is not worth the cost. They will long for Earth, for the sky and wind and water, for the richness of life and the complexity of human society. They might become depressed, resentful, desperate to return but unable to do so. This is a real risk, and it highlights the importance of careful selection, preparation, and support for Mars settlers. Not everyone is suited to life on a frontier, and those who go must understand what they are getting into and be prepared for the reality, not just the romantic vision. The psychological challenges of Mars settlement cannot be overstated. Isolation, confinement, danger, monotony, separation from loved ones, all of these will take a toll on mental health. Settlers will need access to psychological support, opportunities for recreation and social connection, ways to maintain a sense of normalcy and humanity in an abnormal and inhuman environment. They will need to develop coping strategies to find beauty and joy in small things, to build strong relationships with their companions, to maintain hope and perspective. One aspect that might help is the development of rituals and traditions unique to Mars. Humans mark time and create meaning through rituals, holidays, celebrations, ceremonies, practices that connect us to each other and to something larger than ourselves. On Mars, settlers could develop their own rituals, celebrating the anniversary of the first landing, marking the seasons of the Martian year, honoring those who have contributed to the community or who have died. These rituals would help create a sense of continuity and identity, a Martian culture that is distinct from Earth cultures, but equally meaningful. Art and creativity would also be important. Humans need beauty, need to express themselves, need to create and appreciate art. On Mars, settlers might write stories, compose music, create visual art, all inspired by their unique environment and experience. Martian art would be different from Earth art, shaped by the red landscapes, the alien sky, the challenges and triumphs of life on another world. This art would not only enrich the lives of Martians, but also serve as a bridge to Earth, sharing the Martian experience with those who remain behind. Education on Mars is another critical issue. Children will need to be educated. But what should they learn? The basics of reading, mathematics, and science are universal. But beyond that, the curriculum would need to be adapted to Martian conditions and needs. Children would need to learn about life support systems, about the history and geography of Mars, about Earth and its distant relationship to their home. They would need practical skills, how to repair equipment, how to grow food, how to survive in an emergency. But they would also need humanities, literature, history, philosophy, art, the subjects that make us human and give life depth and meaning. The challenge is balancing practical education with liberal education, preparing children for the specific demands of life on Mars, while also giving them the broad knowledge and critical thinking skills that allow them to be fully human. Earth education systems struggle with this balance, and Mars education would face the same challenges, perhaps more acutely given the harsh environment and the limited resources. Language is another interesting question. Would Mars develop its own dialect or even language over time? Languages evolve when populations are isolated from each other, and Mars would be profoundly isolated from Earth. Martian English or Martian Mandarin or whatever language the settlers speak might drift over generations, developing new words for Martian phenomena, new grammatical structures, new pronunciations. Eventually, Martian languages might become distinct enough that Martians and Earthlings would have difficulty understanding each other without translation. This linguistic divergence would be both a loss and a gain. A loss because it would reduce the ease of communication and increase the sense of separation. A gain because it would reflect the unique identity and experience of Martians, their distinctness as a people. Language is not just a tool for communication, but a carrier of culture, and a Martian language would embody Martian culture in ways that an Earth language never could. Let us think about the timeline of Mars settlement. When might this happen? How long would it take? These are speculative questions, but we can make some educated guesses based on current trends and technological trajectories. The first human missions to Mars are likely to occur in the coming decades, perhaps in the late 2030s or 2040s. These will be exploration missions, small crews, spending a few months on the surface before returning to Earth, similar to the Apollo missions to the Moon, but on a much larger scale and duration. Following these initial missions, if they are successful, there might be a phase of more frequent missions, gradually increasing the duration and complexity of human presence on Mars. This phase could last several decades, with missions staying longer, building more infrastructure, testing life support systems, and resource utilization technologies. During this phase, Mars would still be an outpost, not a settlement. People would rotate in and out, and no one would stay permanently. The transition to permanent settlement would require a significant shift in commitment and capability. It would mean building habitats designed for long-term habitation, developing reliable systems for producing food and water, establishing supply chains and logistics that can sustain a population without constant resupply from Earth. This transition might occur in the mid to late 21st century if funding, technology, and political will align. But it is also possible that it could take much longer, or that it might never happen at all. Many factors could delay or prevent Mars settlement. Cost is a major barrier. Sending humans to Mars is extraordinarily expensive, and sustaining a settlement would require ongoing investment for decades or centuries. If priorities shift, if economic downturns occur, if political support wanes, the Mars project could be indefinitely postponed. Technology is another barrier. While we have made great progress, there are still significant technical challenges to solve, and some of them might prove harder than expected. If key technologies fail to develop, or if unexpected problems arise, the timeline could be pushed back. There is also the possibility that we will decide Mars settlement is not worth pursuing. As we learn more about Mars and about the challenges of living there, we might conclude that the costs outweigh the benefits, that resources would be better spent on other goals, that the human and ethical costs are too high. This would be a legitimate choice, not a failure, and it would reflect a mature assessment of priorities and values. But let us assume, for the sake of contemplation, that Mars settlement does occur, that by the end of this century or the beginning of the next, there are permanent human communities on Mars. What would life be like 100 years from now, or 200 or 500? This is where speculation becomes truly imaginative. But it is worth exploring because it helps us think about the long-term implications of the choices we make today. 100 years from now, Mars might have a population of tens of thousands, living in multiple settlements distributed across the planet. These settlements might be clustered in regions with favorable conditions, near the equator for warmth and solar power, near the poles for access to water ice, in valleys and canyons for protection from radiation and dust storms. The settlements would be connected by transportation networks, rovers for surface travel, perhaps underground tunnels for protection from the harsh environment, maybe even early forms of aerial or ballistic transport. The economy would be more diversified than in the early days. There would be agriculture and greenhouses and underground farms, manufacturing using local resources, research facilities studying Mars and the broader solar system, tourism and hospitality for visitors from Earth, creative industries producing content and culture. Mars might export specialty products that can only be made in low gravity or in the unique Martian environment, certain types of crystals, materials, or technologies. It might also export services, data processing, research, education, financial services that can be done remotely. The population would be more diverse, including not just the highly trained specialists of the early days, but families, children, elderly, people with a wide range of skills and backgrounds. There would be schools, hospitals, recreational facilities, places of worship, all the institutions of a normal society. Mars would feel less like a frontier outpost and more like a home, a place where people live full lives, not just survive. 200 years from now, if settlement continues to grow, Mars might have millions of inhabitants, rivaling or exceeding the population of many countries on Earth. Cities would have developed with all the complexity and culture that cities embody. There would be Martian literature, Martian music, Martian art, Martian philosophy, all distinct from Earth traditions while still connected to them. There would be political institutions, perhaps a Martian government or federation of settlements, managing resources and mediating disputes and representing Martian interests. The relationship with Earth would be different at this stage. Mars would no longer be dependent on Earth for survival, but would be a partner, trading and cooperating as equals. There might be regular travel between the planets, with people moving back and forth for work, education, tourism, or personal reasons. Or there might be growing separation, with the two worlds drifting apart as their interests diverge and their cultures differentiate. 500 years from now, if the project succeeds and endures, Mars might be fully transformed, either through terraforming or through the development of extensive artificial habitats. If terraforming has progressed, Mars might have a thicker atmosphere, warmer temperatures, perhaps even liquid water on the surface, though it would still not be breathable and would require centuries more work to achieve that. If artificial habitats have expanded, Mars might be covered in domed cities and underground complexes, with the population in the hundreds of millions or billions rivaling Earth. At this stage, Mars would be fully autonomous, a civilization in its own right, with its own history, identity, and destiny. Martians might see themselves as distinct from Earthlings, as a separate branch of humanity adapted to a different world. There might be further expansion beyond Mars to the moons of Jupiter and Saturn, to the asteroids, perhaps even to other star systems. Mars could serve as a stepping stone to the wider galaxy, a second home from which humanity continues its expansion. But all of this is profoundly uncertain. We do not know if Mars settlement will succeed, if it will last, if it will grow. We do not know if the challenges will prove insurmountable, if the costs will become unbearable, if the human toll will be too high. We do not know if we will choose to pursue this path, or if we will turn our attention and resources elsewhere. The future of Mars depends on choices we have not yet made, on technologies we have not yet developed, on values we are still negotiating. What we do know is that Mars is there, a real place with real possibilities, waiting for us to decide whether and how to engage with it. The question, will we live on Mars, is ultimately a question about who we are and who we want to become. It is a question about our priorities, our values, our vision for the future. It is a question about whether we are satisfied with remaining on one planet or whether we feel compelled to expand. Whether we see the universe as something to explore or something to observe from a distance. There are good arguments on both sides. Those who advocate for Mars settlement see it as inevitable, desirable, even necessary. They argue that expansion is part of human nature, that exploring and settling new frontiers has always driven progress, that becoming multi-planetary makes humanity more resilient and reduces existential risk. They see Mars as an opportunity for renewal, for innovation, for creating something new and perhaps better than what exists on Earth. Those who are skeptical or opposed see Mars settlement as a distraction, a waste of resources that could be better spent on solving Earth's problems. They argue that Mars is inhospitable and will always require artificial support, that we should focus on preserving and restoring Earth rather than abandoning it for a barren desert planet. They worry about the ethical implications, the possibility of exploitation and inequality, the risks to human health and well-being. They question whether we have the wisdom to settle another world responsibly when we have done so much damage to our own. Both perspectives have merit. Mars settlement is neither purely good nor purely bad, neither clearly wise nor clearly foolish. It is complex, multifaceted, full of trade-offs and uncertainties. Our response to it should be thoughtful, nuanced, informed by both enthusiasm and caution. We should pursue the possibility with open eyes, understanding the challenges and costs, weighing them against the potential benefits, and being willing to change course if the balance shifts. Perhaps the most important thing is to approach Mars with humility. We should not assume that we can or should reshape worlds at will, that technology will solve all problems, that expansion is always progress. We should recognize the limits of our knowledge and capabilities, the possibility of unintended consequences, the value of what we might lose, and the pursuit of what we might gain. Humility does not mean passivity or fear, but it does mean proceeding carefully, learning as we go, listening to diverse perspectives, and being willing to admit mistakes and change direction. If we do settle Mars, we should do it in a way that honors both Earth and Mars, that respects the value of both preservation and exploration, that balances ambition with responsibility. We should do it cooperatively, as a species working together rather than as nations and corporations competing for advantage. We should do it justly, ensuring that the benefits are shared and the burdens are not borne disproportionately by the vulnerable. We should do it sustainably, building settlements that can endure for generations, that do not consume resources faster than they can be replenished, that leave room for adaptation and evolution. This is a tall order, and it is not clear we are capable of meeting it. Human history is full of examples of expansion and settlement that were destructive, exploitative, unsustainable. We have often prioritized short-term gain over long-term welfare, individual advantage over collective good, domination over cooperation. If we carry these tendencies to Mars, we will likely replicate the same problems there that we have created on Earth. But we also have examples of cooperation, of communities that function well, of societies that balance individual freedom with collective responsibility. It is possible to do better if we choose to. So will we live on Mars? The answer is, it depends. It depends on us, on the choices we make, on the values we embrace, on the future we decide to create. Mars is there, patient and indifferent, waiting. It will not come to us. We must go to it. And whether we go and how we go and what we do when we get there, all of this is up to us. The future is not determined but open, full of possibilities, constrained by physics and resources, but shaped ultimately by human will and imagination. As you drift now into sleep, let Mars fade from your mind, a distant red point becoming indistinct, blending into the darkness of closed eyes and approaching dreams. Mars will still be there when you wake, still waiting, still silent. And the question will still be there too, waiting for an answer that may come in years or decades or centuries, or that may never come at all. For now it is enough to have asked the question, to have thought about it, to have imagined the possibilities. Tomorrow will bring its own concerns, its own decisions, but tonight, rest. Let the red planet spin in its orbit. Let the future remain uncertain. Let sleep carry you away from questions and into the quiet peace of not knowing, of simply being here on Earth, under our own familiar sky. Sleep deeply now. The brown noise will continue for a little while longer, a constant companion, keeping you in restful slumber. And when you wake in the morning, you'll carry with you the memory of this journey, this exploration of the layers of reality, this glimpse into the deep structure of everything that is. Good night. Rest well. And may you dream of the cosmos in all its layered, mysterious, beautiful glory.